Hello everybody, hope everyone's doing good. In today's session 3, CAMS, we will discuss regarding the motion of the follow. In the session 2 earlier, we already discussed a part of the motion of the follow topic. So this in today's session is a continuation of that. In last session, we have seen or discussed the types of follower motion. Can be of 4 types: uniform velocity, simple harmonic motion, uniform acceleration and retardation motion, and cycloidal motion. In the earlier session, we discussed in detail regarding uniform velocity and simple harmonic motion, and also we have solved a problem each regarding the same. In today's session, we will discuss regarding uniform acceleration and retardation motion and cycloidal motion. So, here the sketch shows the displacement, velocity and acceleration diagram when the follower moves with uniform acceleration and retardation motion. We can see from the diagram that the displacement consists of a parabolic curve, and we'll discuss now how to draw the same. So initially we need to take a suitable scale for the angular displacement, that is theta naught and theta r, as discussed in earlier problems. After drawing the suitable scale, then draw the value of S, that is the lift of the follower, and complete the rectangle. Once after doing that, divide the angular displacement of the cam during outstroke, that is theta naught, into any even number of equal parts. Now here in the figure, it has been divided into 8 equal parts. After dividing, draw vertical lines through these points as shown in the figure. The same has to be done for theta naught, theta r also, that is during the return stroke. Mark into equal number of parts, that is 8. Then draw the vertical lines. Okay. Then you can mark them. So here in the figure they are marked it as A 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 for the theta naught, and 1 dash, 2 dash, and so on for theta r. Now once that has been done, divide the stroke, that is S, into the same number of equal parts, 8. Okay. So to divide the stroke, take the center, say, so here it is 8, so you take the vertical line 4, and in that you just divide that into 8 number of equal parts, and here they have named it as small letter alphabets A, B, C, D and up to H. Same way you mark for theta r also. Just divide the here 4 dash into 8 number of equal parts. Now after dividing and naming them, join the lines. Here the joining has to be done to AA, that is capital letter A to small letter a. So when you join AA, it intersects the vertical line through point 1, and you can mark it as P. Similarly, obtain the other points by joining A to B, A to C, A to D, A. Okay, that's it. So when you join all these lines, those lines will intersect 2, 3 and 4 respectively, and just you mark them on that C, D and E. Same way, join from J to E, J to F, J to G. Okay, so here again it will intersect the vertical lines 5, 6, 7, 8, and you can just mark accordingly like F, G, H. Okay, so on. Same way, now join all these points to obtain a parabolic curve for the outstroke of the follower. In the similar way, the displacement diagram for the follower during the return stroke may also be drawn. Same way we have to follow it, how we have already drawn for the outstroke, the same way will be done for the return stroke. So that completes the displacement diagram. Next, Coming to the velocity and acceleration diagram, uh, for this we need to remember these formulas to measure to calculate the velocity and acceleration. So here S represents the stroke of the follower, theta naught and theta r equals angular displacement of the cam during off stroke and return stroke, and omega represents the angular velocity of the cam. Now to calculate the maximum velocity of the follower during off stroke, we have the formula V naught equals 2 omega s by theta naught. Same way, to calculate the maximum velocity of the follower during return stroke, Vr equals 2 omega s by theta r. So these two formulas will be used to calculate the maximum, to calculate the velocity of the follower during out stroke as well as return stroke. Coming to the to calculate the acceleration of the follower, we have these two formulas. A naught equals 2 omega square s by theta naught square. So this formula is used to calculate the maximum acceleration of the follower during off stroke. Similarly, we have AR equals 2 pi omega square s by theta r square. So this formula is used to calculate the maximum acceleration of the following during return stroke. So these are the formulas that we should remember. So the same will be used for calculating the acceleration as well as the velocity. Hello everybody, hope everyone's doing good. In today's session 3, CAMS, we will discuss regarding the motion of the follower. In the session 2 earlier, we already discussed a part of the motion of the follower topic. we directly make use of these formulas. So here the notations again same. We have theta. Theta represents the angle through which the cam rotates in time t seconds. Then we have omega, that is the angular velocity of cam. So to calculate the velocity of the forwarding of stroke and return stroke, we make use of these formulas. Okay, V naught is equal to 2 omega s by theta naught, and that is for the maximum velocity of the forwarding of stroke, and Vr equals 2 omega s by theta r for the maximum velocity of the follower during return stroke. Same way to calculate the acceleration, it's given as a naught, that is maximum acceleration during out stroke, that is 2 omega square s by theta naught square, and also the maximum acceleration followed during return stroke, AR equals 2 omega square s by theta whole square. So these formulas has to be remembered to calculate the acceleration and velocity. So remember these formulas to measure to calculate the velocity and acceleration. So here S represents the stroke of the follower, theta naught and theta r equals angular displacement of the cam during off stroke and return stroke, and omega represents the angular velocity of the cam. Now to calculate the maximum velocity of the follower during off stroke, we have the formula V naught equals 2 omega s by theta naught. Same way to calculate the maximum velocity of the follower during return stroke, Vr equals 2 omega s by theta r. So these two formulas will be used to calculate the maximum, to calculate the velocity of the follower during out stroke as well as return stroke. Coming to the to calculate the acceleration of the follower, we have these two formulas. A naught equals 2 omega square s by theta naught square. So this formula is used to calculate the maximum acceleration of the follower during off stroke. Similarly, we have AR equals 2 pi omega square. Next, coming to the cam profile. So, in the knife edge follower, we should remember there's a difference between when drawing the cam profile for knife edge and for a roller. When we are drawing for the knife edge, the pitch circle, right? What we call as the prime circle. For a knife edge and flat face, for these two followers, repeat again, for knife edge and the flat face follower, the prime circle and the base circle are identical, because a knife edge and a flat, the it will be in direct, the knife edge, the edge will be as well as a flat face follow, there will be the contact, the prime, it will be in touch with the base circle exactly. So it will be same, that is the prime circle and base circle are identical, but not in the case of a roller follower. Roller follower, the prime circle is larger than the base circle by the radius of the roller. So that has to be taken care. So whenever we're drawing by using roller follower, the prime circle has to be drawn. And the prime circle will always be greater than the base circle. That is by the radius of the roller. So initially, first we need to draw a base circle with center O and radius equal to the cam that has been given, that is 25 mm. Now once the base circle has been drawn, next we need to draw the prime circle. Okay, the prime circle again is drawn with center O, but here the value of the prime circle will be greater than that of the base circle. And how much it will be greater than? It will be greater than radius of the cam, that is 25 mm, plus we have to add the radius of the roller. So here that given the die of the roller as 20, so the radius will be 10. So the total radius will be 25 plus 10. So it will be 35 mm. That is will be the radius of the prime circle. Okay. So next we have to draw the prime circle. Now once the prime circle has been drawn, draw the angles, that is AO, that is the we have to represent the outstroke, dwell and the return stroke on the based on the prime circle, as we have discussed in the earlier two problems. Okay. So whenever we represent the outstroke, dwell and the return stroke, it has to be represented on the prime circle as shown. So we have to divide that circle into 120 degree, 30 degree and 60 degree. So this represents the outstroke, dwell and return stroke respectively. Now after you have marked the degrees, divide the angular displacement of the cam, that is the angle as represented here as AOS and TOP, into equal number of even parts as in the displacement diagram. So in the displacement diagram we are divided into 6 equal parts, so do the same here also. Now join the points, that is 1, 2, 3 etc. with center O, and produce the lines beyond the prime circle as shown in the figure. So in the earlier, in the knife edge, we used to produce the lines beyond the base circle, but in the case of roller follower, it has to be produced beyond the prime circle and marked there. Okay. Now once that has been done, measure the values of 1B, 2C, 3D from the displacement diagram by using a compass and transfer the same to the figure, to the cam profile as shown with so whenever we are transferring the values from displacement diagram, that is value of 1B, you for example if we measure 1B, measure it, and here coming back to the cam profile, here take 1 as the center and cut an arc. Okay, same way go back, measure 2C from the displacement diagram, come back to the cam profile, take 2 as the center and cut an arc on that line. Same way complete transfer all the values from displacement diagram to the cam profile. Okay, so once that has been done, join the points. Okay, join the points, that is the arc that has been cut, join all those points, and here the marking has to be done as A, B, C, so it continues up to P. Now join all the points and join all the points by a dotted curve, and this curve represents the pitch curve. Okay, remember that's not the cam profile, it's the pitch curve. Now once the pitch curve has been drawn, from the same points, that is A, B, C, D up to P, draw circles equal to radius of the roller, that is 10 mm. Join circles for all those points. Now once all the circles has been drawn, remember join the bottom of the circle with smooth curve as shown in the figure. Okay, now this represents the profile of the cam. Once you have drawn the circles of the equal to the radius of the roller, join the bottom. Okay, remember join the bottom of the circle with a smooth curve, and this represents the required profile of the cam. So this completes the profile of the cam when the axis of the follower and the axis of the cam are same. Next, for pitch of the we'll discuss how to draw the profile of the cam when the line of the stroke is offset by 15 mm from the axis of the shaft. So once this the procedure that we have followed for earlier, the same will be followed here also. So initially again we need to draw the base circle with center O and the radius equals to 25 mm. So once the base circle has been drawn, we know that this is a roller follower. So whenever a roller follower is same, then we need to draw the prime circle. So we need to draw the prime circle with center O and radius equal to 35. We have discussed how we get that the value of 35 mm. So 35 mm we draw that radius. After that, here they have mentioned this offset. Okay, so we need to draw an offset by 15 mm. So draw an offset circle with center O and radius equals to 15. Okay. Now, when after drawing the offset circle, if we just draw a, on the draw a straight line of the offset circle, it intersects the prime circle at point O. Okay, so we can mark it as that A. So we just join OA. After joining OA, draw the represents the out stroke, dwell, and the return stroke. Like here we have marked it as AOS is equals 120 degree, and angle SOT as 30 degree, and angle TOP is 60 degree. Just mark those angles. Now after marking those angles, divide again into equal number of parts as that of the displacement diagram. Now once after dividing it from the points 1, 2, 3 and so on, and 1 dash, 1 dash, 2 dash, just extend the lines on the prime circle. Okay, here when we extend the line, we should make sure that the lines should be drawn tangent to the offset circle. Okay, so whenever they say offset, we have to draw tangent to the offset circle. Now once that has been done, the same process, transfer the values that is from the displacement diagram, values of 1B, 2C and 3D, and transfer it to the cam profile here with the 1, 2, 3 as the center. Now join the points A, B, C with a smooth curve, and remember this smooth curve represents the prime circle. Now once the prime circle has been drawn, again draw the now with the A, B, C as center, draw circles, and this circle will be having radius equal to that of the radius of the follower. Draw the circles for A, B, C, A, E, F, G, H and up to P. After joining all the circles, join the bottom of circles with a smooth curve as shown in the figure. This smooth curve represents the required profile of the cam. So this completes the profile of the cam has been offset by 15 mm. See the process, the offset to draw the offsets is very similar what we discussed earlier problems also, but only thing is that here we are drawing the offset circle. So whatever the value they mentioned of the offset, that has to be drawn, and the rest of the procedure is same. Okay, so there's not much changes. So this is how to draw the profile of the cam when the follower is of roller type, remember. But if the follower is of knife edge or if it's a flat faced, then there is no need of the prime circle. Okay, so remember these points. So anyhow, I'll be sharing the step-by-step process, the handwritten notes. I'll be sharing it, posting it on the group. You can just go through that once again. And if any doubts, please let me know, or you just can give me a call at any time. Okay. So this completes today's session. Thank you.